Let's translate some parabolas. I noticed some things in y equals x squared plus 2. The first thing I notice is that our a value is 1. So the a value is the number that may or may not be multiplied by x squared. So in the case of just having an x squared, that's the same thing as 1 times x squared. Okay, but then we have this plus 2. So let's see how that changes things. I've started a table here with inputs already laid out, and I've just picked some numbers. It's usually a good idea to be somewhere close to 0 because quadratics can get really big pretty quickly. If we plug in -3 for x, -3 squared is 9. 9 plus 2 is 11. -2 squared is 4. 4 plus 2 is 6. -1 squared is 1. 1 plus 2 is 3. 0 squared is 0. Plus 2 is 2. 1 squared is 1. Plus 2 is 3. 2 squared is 4. Plus 2 is 6. 3 squared is 9. Plus 2 is 11. So I can see that our numbers start pretty high and then go down until they reach this point right here at 0, 2. And then they start increasing again. And I see that these last 3 numbers are the mirror image of the first 3 numbers. That tells me that this point 0, 2 is my vertex. So I go left to right 0, up 2. And then since these are mirror images of one another, what I can do is I can graph just one arm of that parabola, and then the other one will just be a mirror image of that. So 1, 3, 2, 6, and 3, 11 would be off our graph. It would be something like up there. So our parabola looks like this. If you think back to what we called the parent function in the first video, the parent function's y equals x squared, and it has the vertex at 0, 0. So what happened to the parabola? It looks like this parabola was shifted up by 2 units. And sure enough, in the equation y equals x squared plus 2, I see that it appears that the parabola is shifted up by 2 units. So that means our vertex was at 0, 2. And again, once you find the vertex, you can graph the parabola, even if it just means that you'd be starting the table at the vertex and then just picking some x values really close to that. So if I know the vertex is at 0, 2, I could pick 1, 2, and 3 for good x values and calculate the y's and then just plot those points. Let's do another one. Y equals x squared minus 3. I'm going to form a hypothesis here. This first problem we did, y equals x squared plus 2, the plus 2 shifted the parabola up 2 units. So I'm going to guess that this shifts the parabola down 3 units. Let's plug in these numbers and find out. -3 squared is 9, minus 3 is 6, -2 squared is 4, 4 minus 3 is 1, -1 squared is 1, 1 minus 3 is -2, plug in 0, get -3, plug in 1, get -2, plug in 2, get +1, plug in 3, get 6. And again, I notice my numbers decrease, 6, 1, -2, until we get to the point 0, -3. And then from there, the numbers start increasing again. Those are mirror images of one another, which indicates that that point 0, 3 is our vertex, exactly where we thought it would be. So our vertex is at 0, -3. We can graph just the vertex and points on one side, one arm of the parabola. I will plot those points now. And as soon as we get the points on one side, we can make the mirror image of the points on the other side. Hooray for symmetry! So y equals x squared plus 2 shifted it up by 2 units. And y equals x squared minus 3 shifted it down by 3 units. Both of those problems that we've done had the extra number, the plus 2 and the minus 3, were outside of the squared. So we had x squared plus 2x squared minus 3. This next problem is a little different than that because we have the number subtracted inside the squared. So it's in with the x. Let's see what happens when we plug in these numbers. Negative 3 minus 2 is negative 5 squared is 25. Negative 2 minus 2 is negative 4 squared is 16. Negative 1 minus 2 is negative 3 squared is 9. 0 minus 2 is negative 2 squared is 4. 1 minus 2 is negative 1 squared is 1. 2 minus 2 is 0 squared is 0. 3 minus 2 is 1 squared is 1. It looks at first like our pattern is broken here. What if we just did just a little bit more on this table? If we plugged in 4 for x, we would have 4 minus 2 is 2, 2 squared is 4, and we can start to see the pattern again. Our numbers, as x increases, these numbers are all decreasing, not till 0, 4, but instead they're decreasing till 2, 0. That is going to be our vertex because it's after that that we start seeing the same pattern. 1 and a 4, 1 and a 4. Our vertex is at 2, 0, so it's shifted to the right 2 places. From knowing the vertex, we can plot the rest of this pretty quickly. We can just grab one arm, 3, 1, 4, 4. And I know that by symmetry, we have the points on the other side as well. So there's approximately our parabola. Looking at this, x minus 2 ended up shifting it to the right 2 places. This next problem, we have x plus 4, again, inside the square symbol. So it's in close with the x. Since y equals x minus 2 squared, shifted it to the right 2 places, I'm going to guess that y equals x plus 4 squared shifts it to the left 4 places. I purposefully didn't fill our table because I wanted to hit on either side of this negative 4. So I'm going to guess that a negative 4 is right in the middle there. And then I'll plug in negative 3, negative 2, negative 1, negative 5, negative 6, negative 7. And I'm going to start at this negative 4. So negative 4 plus 4 is 0. That's our key right here. Negative 4 plus 4 is 0. 0 squared is 0. If we go to either side of it, plug in either negative 5 or negative 3, we're going to get the same y value. Negative 5 plus 4 is negative 1. Negative 1 squared is 1. Negative 3 plus 4 is positive 1. Positive 1 squared is 1. So it's by virtue of this being squared that as long as the absolute value of that input is the same, we're going to have the same output. I should get the same number for y if I plug in negative 6 or negative 2 for the x value. So if I plug in negative 6 plus 4 is negative 2. Negative 2 squared is positive 4. Same thing, if I plug in negative 2, I'll leave that check for you. If I plug in negative 1 or negative 7, I should get the same output. Negative 1 plus 4 is positive 3. Positive 3 squared is 9. And you can go ahead and pause the video and check if that's the case for negative 7 as x value as well. So what happened here is our vertex is at negative 4, 0. That means this graph was shifted to the left 4 places. Plotting this, I'm going to start at the vertex, negative 4, 0, and then just plot one arm of this parabola. Once I have one arm plotted, the other one is the same through symmetry, and our parabola looks like that. Let's put these ideas together. I see that x minus 3 squared and then minus 1. So there's two translations or transformations happening right here. x minus 3 means that we're shifting 3 places to the right. The minus 1 means we shift down 1 place. So that means our vertex should be positive 3, comma, negative 1. I am going to ignore the x values in our table and just plot from an x value of positive 3, negative 1, and I'll pick some x values right next to that. I'll pick 4 and 5. When x is 4, 4 minus 3 is 1, 1 squared is 1, 1 minus 1 is 0. When x is 5, 5 minus 3 is 2, 2 squared is 4, 4 minus 1 is 3. Let's do another one. When x is 6, 6 minus 3 is 3, squared is 9, minus 1 is 8. Now I'm going to plot those points knowing that 3 comma negative 1 is our vertex. That's our bounce point. And there is our parabola. To take away, what we're doing is we're building towards something called vertex form. We've already talked about what A is. A is the stretch or shrink factor. It controls how quickly or how slowly our parabola grows. X minus h, quantity squares. The minus h is important because that is our reminder that the x coordinate is going to be opposite whatever that appears inside the parentheses. And then we have plus k, and the k controls our up and down movement. A is the stretch or shrink, h is the horizontal shift, and k is the vertical shift. So we can have any quadratic thrown at us in this form, and we can read the vertex right off. I can tell a lot of information from this equation. So to start with, I see that my parabola is scaled at a factor of 2. So that means it's going to be growing faster. It's going to appear narrower than my parent function. And it's also going to open upward, and I know that because that 2 is a positive. It's a narrow parabola that's opening upwards. The x plus 1 tells me that it's shifted left by 1 place. And then this minus 6 tells me that it's shifted down by 6. So our vertex would be the point -1, -6. Thank you.